Awesome. Okay. Okay. వస్తుందా సార్ స్టార్ట్ చేయమంటే హలో డోర్ అంట hello everyone, today we are going to continue the next session for 9th class behavior of gases from toppers JEE NEET foundation NEET foundation. So already in previous session we have completed some single correct answer type questions. Today we are going to continue with the some other single correct answer type questions. Okay, let us start our session. See the first question. 5 liters of a gas is collected at 100 Kelvin and then allowed to expand to 20 liters. What is the new temperature in order to maintain the same pressure? So, if you read the problem clearly, we can understand that here the problem is with volume and temperature relationship. Volumes are given and temperature is given. He is asking to calculate the new temperature. Okay, let us see, write first data from the given problem. 5 liters of a gas is collected at 100 Kelvin. So 5 liters means volume, V1 is given. So V1 equal to 5 liters and collected at 100 Kelvin. 100 Kelvin means temperature is given, T1 equal to 100 Kelvin. Next, and then allowed to expand to 20 liters. So V2 also given, V2 equal to 20 liters. And then what is the new temperature in order to maintain the same pressure? So he is asking to calculate T2. So it is the relation for Charles law. At constant pressure, he is asked what is Charles law? At constant pressure, volume is directly proportional to its temperature. So V1 is given, T1 is given, V2 is given, and he is asking to calculate for T2. So what is the relation for Charles law? V proportional to T, V equal to some constant K into T. So V by T equal to K. Then at two different temperatures or volumes is considered, V1 by T1 equal to V2 by T2. So this is the formula we are going to use here. Already V1 by T1 equal to V2 by T2, V1 is given 5 liters, T1 is given as 100 Kelvin, V2 is 20 liters, then we have to calculate T2. So this is the given data and this is the formula we are using for this problem, and then calculation. Just substitute the given data in the formula. V1 means 5 liter by T1 is 100 Kelvin, V2 20 liters by T2 we have to calculate. So T2 equal to 20 into 100 divided by 5. So 5 4, so answer is 400 Kelvin. Let us check the options. In the first option 273 Kelvin, second option 300 Kelvin, and third option is 400 Kelvin, which we got. So the correct answer is C, 400 Kelvin, and D, 200 Kelvin is also not correct. So this is the problem they asked to do. Okay, fine. Then comes to the next one. A balloon full of air has a volume of 2.7 liters. So while reading the problem only we have to write the data, then it will be clear to do the problem and which formula we have to use. Let's write the given data. Volume is given, so V1 equal to 2.75 liters. At a temperature of 18 degrees Celsius. So temperature is given T1. How much? 18 degrees Celsius. And then what is the balloon's volume? He is asking to calculate V2 at 45 degrees Celsius. So T2 at 45 degrees Celsius. So at 18 degrees Celsius, volume of the balloon is 2.75 liters. At 45 degrees Celsius, what is the volume of the balloon is the question. First of all, we have to convert this 18 degrees Celsius into Kelvin. From degrees Celsius to Kelvin, we have to convert by adding 273 Kelvin. So 18 plus 273 gives you the temperature. This 45 degrees Celsius also you have to convert into Kelvin. Then 45 plus 273. Just add here 3, 11, 9, 291 Kelvin. So T1 is 291 Kelvin and T2 is 318 Kelvin. So 45 plus 273 is 318, 18 plus 273 is 291 Kelvin. So V1 is given, T1 is given, V2 we have to find and T2 is given. So the formula we are going to use same like previous problem, V1 by T1 equal to V2 by T2. Sorry, so we have to calculate here V2, then V1 T2 by T1. Just substitute the given values in this formula. V1 is 2.75 liters. I'll write here 2.75 liters into T2 is 318 Kelvin by T1 is 291 Kelvin. By calculating this we can get the answer. So this is the problem how we have to do. If you calculate this you will get obviously 3 liters. So we are going to with the B option. So this is also according to the Charles law only. He kept the pressure constant and given volume and temperatures. By changing the volume and temperature we have to substitute the given values and we will get the answer. Okay, comes to the next question. How many grams of nitrogen gas will exert a pressure of 760 mm of Hg in a 11.2 liter container at 273 Kelvin? So by reading the problem we have to understand what is the data given first. Either pressure is given, volume is given or temperature is given. What is given we have to understand. How many grams of nitrogen? So he is asking to calculate weight. How many grams? So we have to know weight first. Will exert a pressure. So how much pressure is given? 760 mm of Hg. In a 11.2 liter container, 11.2 is the volume. So 11.2 liters volume is given. Container at 273 Kelvin. So temperature is given 273 Kelvin. So this is the data we got from the given problem. So by seeing this data P, V, W we have to calculate and temperature is also given. So here we have to use the combined gas laws, means ideal gas equation. PV equal to nRT. Here this one we have to convert because he is asking to calculate the weight. See P, V, N is nothing but number of moles. Number of moles is weight by molecular weight into R into T. So from the given data we know pressure, volume, temperature also we know, and R is the universal gas constant and its value we have to take in liter atmosphere because volume is in liters and pressure is given in mm of Hg. This one we can convert into atmospheres by dividing with another 760. So you will get 1 atmosphere. So obviously R value in liter atmospheres is 0.0821 liter atmosphere per mole and Kelvin. By substituting all these values here we will get the answer N. Okay, see. Come to here. Liter container. Nitrogen. So molecular weight, see here, molecular weight of nitrogen is, for 1 nitrogen it is 14, for 2 nitrogens it is 28. So molecular weight of nitrogen is 28. We want weight, so I am altering, I am taking the formula here again. PV equal to weight by molecular weight into RT. I want weight, so simply I will convert this formula as PVM by RT. All the values we have, simply substitute those values, we will get the answer. P is 1 atmosphere and volume is 11.2 liters and molecular weight is 28 by R is 0.0821 into temperature 273 Kelvin. So by calculating this one, we will get the final answer. How many grams of nitrogen gas will exert pressure of 760 mm of Hg in 11.2 liter container at 273 Kelvin. By calculating this one, we can get the answer. Okay, see. Come to the next one. Which of the pairs of gases diffuse at lower rate than CO2? See, this is about the rate of diffusion of gases. Already we know the statement regarding rate of diffusion of gases. R is inversely proportional to square root of its density. Once it is inversely proportional to square root of its density, obviously we can take this formula as rate of diffusion is inversely proportional to square root of its molecular weight. So, the question, which of the pairs of gases diffuses at lower rate? Which diffuses at lower rate? Rate is less, so we have to choose the high molecular weight compounds. Higher molecular weight compounds will diffuse lower rate. Okay, so from the given options, which has the high molecular weight, they will diffuse slower. So let us see here, hydrogen, the molecular weight of H2 is 2 and helium is 4. Comes to SO2 and SO3. SO2 molecular weight. For sulfur, it is 32. For one oxygen is 16. So, 2 oxygens it is 32. 32 plus 32 is 64. For SO2, it is 64. Here it is SO3. SO3 means add one more oxygen. Then 64 plus 16. Then that gives you 80 is the molecular weight for SO3. Like that only calculate the molecular weight for nitrogen and carbon monoxide also. For N2, it is 28. For one nitrogen, it is 14. For two nitrogens, N2, it will be 28. Comes to the CO, carbon monoxide. For one carbon, it is 12. Plus for oxygen, it is 16. So, 12 plus 16 will be 28. Here nitrogen is 28 and carbon monoxide is also 28. Let's calculate for D option. N2O. N2 for one nitrogen it is 14. For two nitrogens 28. 28 plus 16. Then it will be 44. Comes to C3H8. For one carbon it is 12. Then 12 3s are 36 plus 8. It will be also 44 only. So, which of the pairs of gases diffuses at lower rate than CO2? So, which has the molecular weight higher than the CO2? They will diffuse slower than this. Here, if in these options, if you observe, which option has the higher molecular weight than CO2? Helium and hydrogen 2,4 lesser than carbon dioxide. SO2 and SO3. For SO2 it is 64 and SO3 it is 80. Higher 44. Carbon dioxide's molecular weight is 44. So 64 and 80 are greater than 44. So they have high molecular weight. So they will have less rate of diffusion than carbon dioxide. So we will go with the option B. Let's check the remaining options also. Nitrogen and carbon monoxide. Nitrogen molecular weight is 28. Carbon monoxide is also 28, which is lesser than CO2. So they will diffuse faster than CO2. Okay. So not even C and D options also. Our option is B. This question will explain based on its molecular weights. Which has the higher molecular weight, they will diffuse lesser. Which has more weight, they will run slow. The same law will be applicable even here also. Which gas has the higher molecular weight, that diffuses slower. Okay, is it clear? So comes to the next question. So till now we have discussed single correct answer type questions. In the previous session also we discussed some single correct answer type questions. So our single correct answer type questions are completed, so we'll go with the multi correct answer type questions. Okay, let's check. Our first question: which of the following are the units of volume? What are the units of volume? Actually, volume means we'll calculate for the liquids and gases, right? So what are the general units for volume? Volume will be in liters, in milliliters, or cubic centimeter cube. See, liters, A option will be correct, B also correct, C is also correct. In kilometers, that kilometer is the unit for speed, not for the volume. So, not the D option. The question: which of the following are the unit is or are the units of volume? Volume units are liter, milliliter and cubic centimeter. Okay, comes to the next question. Which of the following are considered as STP conditions? What is meant by STP first of all? STP, standard temperature and pressure. So, yet STP conditions means we will maintain some standard temperature and pressure. So, always at STP conditions, temperature will be 273 Kelvin. 273 Kelvin means 0 degrees Celsius, and we will maintain the pressure 1 atmosphere. These are called fixed one, and this is standard temperature and pressure condition. So, he is asking which of the following are considered as STP conditions. So, first option is 0 degrees Celsius. Yes. Why? Because 273 Kelvin means 0 degrees Celsius only. So, 0 degree and 1 atmosphere, 273 Kelvin, and even we can consider 76 centimeter of Hg. 76 centimeter of Hg we can convert into atmospheres, then that will be the equal to 1 atmosphere only. So, I will go with the D option also. So, the STP conditions are 0 degrees Celsius, 1 atmosphere, 273 Kelvin and 76 centimeters of Hg. Sorry, come to the next question. The volume of a gas measured at 27 degrees Celsius. This is 27 degrees Celsius. This symbol is for degrees Celsius. This is also degrees Celsius. This is also degrees Celsius. So, come to the question. The volume of a gas measured at 27 degrees Celsius and 1 atmosphere pressure is 10 liters. So, from the first line of the question, we have some data. What is the data? They given temperature as 27 degrees Celsius and they given pressure. How much? 1 atmosphere. And volume is 10 liters. You can get one doubt, how come we know the given one is pressure, the given one is volume? Like according to the units also we can identify what is the data given. Okay, degree Celsius is the unit for temperature, so temperature is given T. Atmosphere is the unit for pressure, so P is 1 atmosphere, and L means liter, liter is for volume, so volume is given 10 liters. Okay, what final temperature would be required to reduce the volume to 5 liters? So, they are asking to calculate final temperature. So, these are the initial ones. So, they are asking to calculate the final temperatures. See, T2, we have to find P2, 5 liters at 1 atmosphere. So, here again pressure is given 1 atmosphere. So, both pressure is same, means at constant pressure they are taking the data. So, V2 is 5 liters. So, already we know the formula. When V1, V2 is given, T1 is given, T2 is asking to calculate, then the formula is V1 by T1 equal to V2 by T2. Sorry. So, T2 equal to V2 T1 by V1. What is V2? According to the problem, 5. And what is T1? 27 degrees Celsius is given. This one we have to convert into Kelvin. So 27 degrees Celsius plus 273 gives you how much? 300 Kelvin. So the temperature T1 is 300 by volume V1 is 10 liters. So 5 2s are 10, 2. So it is 150 Kelvin. Let's see, is it there in the options? 150 Kelvin. See the first option, 450 Kelvin. No. 150 Kelvin. 150 Kelvin is given. Yes, 150 is there. And it is 177 degrees Celsius. See, it is 150 Kelvin. To convert degrees Celsius to Kelvins, we have to add 273. To convert Kelvins to degrees Celsius, we have to subtract with 273. So 150 Kelvin minus 273 gives you answer in degrees Celsius. Let's see, do the subtraction. Then 150, 3, 2, 1. So big number has negative, so I will go with minus 123 degrees Celsius, minus 123 degrees Celsius. So our answer in degrees Celsius is minus 123, in Kelvins is 150. So where is 1? Yes, in D option there is 123, minus 123 degrees Celsius. So our answers are B and D, not A and C. So this is the formula, the formula we have to do. Okay, comes to the next one. Dalton's law of partial pressure is not applicable to. Before going to explain this question, first of all we should know the conditions for Dalton's law of partial pressures. While discussing the Dalton's law of partial pressure, the total pressure equal to sum of its partial pressures. Already we know that P equal to sum of how many partial pressures we are taking, that will be its sum, and so on, we can take till n also. But the condition for this sum of this Dalton's law of partial pressure is, whatever the gases we are taking in a container, those gases should be Yes, whatever the gases we are taking in the container, suppose I am taking A plus B, 2 gases I am taking in a container, and the total pressure exerted by this container is the sum of its partial pressures. What is meant by partial pressure? The pressure exerted by the individual gas in a container. Means A is one of the gas. This A contains some pressure, that individual pressure exerted by A is called its partial pressure. Whereas come to B, B is a gas, it has some pressure. So the partial pressure of B means the pressure exerted by the B individually is called its partial pressure. So we can write the Dalton's law of partial pressure for this total pressure equal to sum of PA plus PB. Sorry, but the main condition for this Dalton's law of partial pressure is the two gases are non-reactive. A and B are not supposed to be reactive. If they react each other, then that is not a Dalton's law of partial pressure. So the question is, Dalton's law of partial pressure is not applicable to. In the given options, which gases are reactive? For those gases, Dalton's law of partial pressure will not be applicable. Comes to the first option. NO and O2 both will be reactive gases only. Those are not non-reactive. Both are reactive gases. Comes to H2Cl2. These also reactive gases only. NH3 plus HCl forms NH4Cl. These also reactive gases only. Comes to CO2 and O2. These two will not react. So the Dalton's law of partial pressure will be applicable to D option. Will not be applicable to A, B, C. So the given question also, Dalton's law of partial pressure is not applicable to. So our options are A, B, C are correct options. Okay, let's go to the next question. Which of the following pairs of gases diffuses at same rate? Generally, already we discussed this type of question in single correct answer type. Means, how can we know which gas diffuses faster, which gas diffuses slower? How to calculate that rate depends upon its molecular weight. So here he is asking, which of the following pairs of gases diffuses at same rate? Same rate means compulsory those two gases should have same molecular weight. They will be diffuses at same rate. Let's check with the options. Come to the first one, N2O. What is the molecular weight? Just simply write the molecular weights for N2O. N2O, for 1 nitrogen it is 14, for 2 nitrogens it is 28, plus for 1 oxygen it is 16. So 28 plus 16 is obviously 44, and for CO2 already we know it is 44, right? Now come to the helium and neon. Helium is 4 and neon. What is the molecular weight of the neon? Neon is 20. Now comes to the nitrogen. Nitrogen is 28 and carbon monoxide, for 1 carbon it is 12 and for 1 oxygen it is 16. Then 12 plus 16 will be 28. Comes to carbon monoxide, it is 28 and for carbon dioxide it will be 44. So now all the compounds we know its molecular weights. Let's see which diffuses at same rate, which have the same molecular formula. They will diffuses at the same rate. N2O and CO2, both molecular weights are 44 only. So they will diffuses at the same rate. Comes to the next option, helium is 4, neon is 20. Their molecular weight is different. So they will diffuses at different rate. So B is not correct. N2 and CO. For N2 it is 28. For CO also it is 28. Both the molecules have same molecular weight. So they will diffuses at the same rate. Next for D, carbon monoxide and carbon dioxide. One is 28, another one is 44. Their molecular weights are also different. So they also diffuses at different rates. So our options are A and C. Both N2 and CO2 44 diffuses at same rate. Both N2 and CO is 28 its molecular weight, so they will diffuses at the same rate. So I will go with the A and C. Okay, now we completed multi-correct answer type questions. So we will go with the next type questions, that is comprehension passage type questions. Okay, let us see what is the comprehension is given. Okay, let us see. At constant temperature, the volume of given mass of gas, at constant temperature, the volume of given mass of gas is inversely proportional to its pressure. This is nothing but called Boyle's law, right? That is the first statement. Next one, at constant pressure, they given constant pressure, right? The volume of given mass of gas, volume of the given mass of gas directly proportional to its absolute temperature. So in the paragraph they given Boyle's law and Charles' law statements. So let us see what are the questions he asked in comprehension and passage type. Let's see the first question. At constant temperature, the pressure of VML of a dry gas is increased from 1 atmosphere to 3 atmospheres. The new volume will be. So he given V1 equal to V. He is asking to calculate V2. But he given information about the pressures. What is that? P1 is 1 atmosphere. P2 will be 3 atmospheres. So the question, at 1 atmosphere's pressure volume is VML. At 3 atmospheres pressure, what is the volume he is asking. So obviously we know the pressure and volume relation means it is Boyle's law. Boyle's law is P proportional to 1 by V. So obviously PV equal to constant. For different gases is consider P1 V1 equal to P2 V2. Now we have to apply this formula. We have to calculate V2. So simply V2 equal to P1 V1 by P2. Substitute P1 V1 and P2 values. P1 is 1 atmosphere, V1 is V, P2 is 3. So it is simply V by 3 ml. At 1 atmosphere volume is VML. At 3 atmospheres volume is V by 3 ml. Let's check with the options. First option is 3V. No. Second option is V by 3, which we got. V3. No. 2V. Actually this is not 3 ma, it is V cube. 2V cube. It is 3V. So not all ACD. The correct answer is B. Okay. Now let's check the next question in passage type. To what pressure would you have to compress 48 liters of oxygen gas at 99.3 kilopascals in order to reduce its volume to 16 liters at constant temperature is given. Obviously at constant temperature means the given one is Boyle's law. So at constant temperature P1 V1 equals to P2 V2. First of all list out the data given. Data, to what pressure would you have to compress 48 liters? So V1 is 48 liters of oxygen gas at P1 is 99.3 kilopascals. Kilopascals is the unit for pressure. In order to reduce volume, so V2 is given 16 liters. So he is asking to calculate P2. So let's substitute all the values in the given formula. Then P2 equal to P1 V1 by V2. P1 is 99.3 kilopascals and V1 is 48 by V2 16 liters. Obviously 16 3s are 48. So multiply 99.3 into 3. We will get the answer. 99 3s are. Here 9. 3 9s are 27. 29 7.9 means 298 kilopascals. So the answer is A option, 298 kilopascals. Okay. So not the B, 197 pascals, 397 is wrong, 50 kilopascals is wrong. So our correct answer is 298 kilopascals. Okay. Comes to the next one. This is the third question from comprehension passage type. At what centigrade temperature will the volume of gas at 0 degrees Celsius doubles itself, pressure remaining constant? So we are keeping pressure constant. So obviously it is Charles' law. What is Charles' law? V proportional to T. So V1 by T1 equal to V2 by T2. This is the formula we have to use for this problem. So what is the data given? Data V1, at what centigrade temperature the volume of gas at 0 degrees Celsius doubles itself. So V1 is V, then V2 equal to 2V, then T1 is 0 degrees Celsius. So at 2V what is the temperature he is asking. Okay, let's substitute. Here degree Celsius I am converting into 273. So because I am converting into Kelvin, so for this 0 degree Celsius I am adding 273 Kelvin. So substitute in the given one. T2 equal to V2 T1 by V1. What is V2 here? 2V. What is T1? 273 Kelvin. By what is V1? V. VV will get cancelled. 273 2 into 2 is nothing but 546 Kelvin. So at 546 Kelvin, the volume of a gas at 0 degrees Celsius doubles itself. Okay. So V becomes 2V at 546 Kelvin. So I will go with the 546 Kelvin. All the answers are given in degrees Celsius. So we have to convert into this kelvins into degrees Celsius. Already while doing the previous problem, we discussed that how to convert the Kelvin to degrees Celsius by subtracting with 273. So 546 minus 273. So obviously it will be 273 degrees Celsius. So 273 degrees Celsius. It is not. This is 273 degrees Celsius, ma. Don't get confused. The option 890 degrees Celsius. Here also 546 degrees Celsius. It is also 0 degrees Celsius. So our answer is C, 273 degrees Celsius. Okay. So today we discussed the remaining part of single correct answer type questions and multi correct answer type questions and some passage questions also we discussed. Okay. Thank you so much.